In the late 1960s, the Cold War was at its peak, and the U.S. Air Force faced a formidable challenge, maintaining air superiority against increasingly advanced Soviet fighters. The Soviet Union's MiG-25 Fox-Bat, a high-speed, high-altitude interceptor capable of Mach 3, exposed vulnerabilities in existing U.S. aircraft like the F-4 Phantom. The MiG-25's ability to outrun and outclimb most Western fighters underscored the need for a new platform designed explicitly for air superiority. The U.S. sought a fighter that could dominate dogfights, intercept threats, and operate in contested skies. This strategic imperative drove the development of the F-15 Eagle, a jet engineered to outmatch Soviet counterparts and secure Western air dominance for decades. The F-15 was envisioned as a no-compromise air superiority fighter, with three core design goals: speed, maneuverability, and advanced systems. The aircraft was built to exceed Mach 2.5, ensuring it could chase down or evade high-speed threats like the MiG-25. Its aerodynamic design, featuring a high thrust-to-weight ratio and low wing loading, delivered exceptional maneuverability for dogfights. The twin Pratt & Whitney F-100 turbofan engines provided over 23,000 pounds of thrust each, enabling a climb rate of 50,000 feet per minute. At the heart of the F-15's technological edge was the N/APG-63 radar, a pulse Doppler system that could detect and track multiple targets at long ranges, even in cluttered environments. This radar, paired with advanced avionics and a heads-up display, HUD, gave pilots unparalleled situational awareness. The F-15's weapons suite, including the AIM-7 Sparrow and AIM-9 Sidewinder missiles, ensured lethality in both beyond visual range, BVR, and close-in engagements. The design prioritized versatility, allowing future upgrades to keep the aircraft relevant. The F-15 program was spearheaded by McDonnell Douglas, now part of Boeing, a leading aerospace firm with experience building the F-4 Phantom. The Vietnam War exposed the F-4's limitations, particularly its lack of a gun for close combat and its reliance on early, less reliable missile systems. These lessons shaped the F-15's requirements, with the U.S. Air Force demanding a fighter optimized for dogfighting while retaining BVR capabilities. McDonnell Douglas collaborated closely with Air Force engineers and pilots, incorporating feedback to ensure the F-15 met real-world combat needs. The project drew inspiration from the agility of lightweight fighters like the F-5, but scaled up with superior power and technology. The F-15's prototype, the YF-15, first flew on July 27, 1972, from Edwards Air Force Base, California. Developing the prototype was a complex endeavor, as engineers integrated advanced systems like the N/APG-63 radar and the powerful F-100 engines into a sleek airframe. Challenges included managing the engine's high thrust, which required precise control systems to prevent compressor stalls, and ensuring the radar's reliability in dynamic flight conditions. The YF-15 underwent rigorous ground testing to validate structural integrity and system compatibility. McDonnell Douglas's iterative approach, refining designs based on test data, ensured the prototype met performance targets, paving the way for production. Producing the F-15 required innovative manufacturing techniques due to its use of advanced materials like titanium, which comprised about 25% of the airframe for strength and heat resistance. Titanium's difficulty to machine and high cost posed significant hurdles. McDonnell Douglas developed specialized tooling and processes to shape titanium components, such as the wing spars and engine mounts. Scaling production for the single-seat F-15A and two-seat F-15B models demanded a robust supply chain for precision parts, including radar components and avionics. The St. Louis, Missouri, facility became a hub for F-15 assembly, with production lines optimized to meet Air Force demand for hundreds of units. The F-15's initial unit cost was approximately $28 million in 1970s dollars, roughly $150 million in 2025 dollars, a significant investment driven by its advanced systems and materials. To manage costs, McDonnell Douglas streamlined production processes and negotiated long-term contracts with suppliers for components like the F-100 engines and N/APG-63 radar. Logistical challenges arose in sourcing specialized parts, such as high-temperature alloys and microelectronics, which required global supply chains. The Air Force mitigated cost overruns by prioritizing modular designs, allowing upgrades without major redesigns. Despite these efforts, budget constraints occasionally delayed production timelines, requiring careful coordination to maintain program momentum. Flight testing began in 1972 at Edwards Air Force Base, where test pilots pushed the YF-15 to its limits. Over 2 years, the aircraft underwent hundreds of sorties to validate its performance metrics, a top speed of Mach 2.5, a service ceiling above 65,000 feet, and a combat radius exceeding 1,000 miles. Tests confirmed the F-15's ability to perform high-G maneuvers and engage simulated targets with its radar and weapons. Challenges included fine-tuning the fly-by-wire controls and ensuring radar performance in adverse conditions. The test program's success, driven by collaboration between McDonnell Douglas and Air Force pilots, cleared the F-15 for production. Early F-15 models faced significant hurdles, particularly with the Pratt & Whitney F-100 engines. Compressor stalls and turbine blade failures plagued initial operations, reducing reliability. Engineers traced these issues to high operating temperatures and airflow disruptions. Iterative fixes, including redesigned turbine blades and improved engine control systems, enhanced reliability by the late 1970s. These improvements were incorporated into the upgraded F-15C, single-seat, and F-15D, two-seat, models, which also featured enhanced avionics and increased fuel capacity. The Air Force's commitment to addressing these issues ensured the F-15's operational readiness. Pilot and strategist input was critical to the F-15's success. Test pilots at Edwards provided detailed feedback on handling, praising the aircraft's responsiveness but requesting refinements to cockpit ergonomics and radar interfaces. Air Force strategists emphasized the need for robust BVR capabilities to counter Soviet numerical advantages. This feedback led to upgrades like the improved APG-70 radar in later models and the integration of the M61 Vulcan cannon for close combat. Continuous dialogue between McDonnell Douglas and the Air Force ensured the F-15 met evolving operational demands. The F-15A entered U.S. Air Force service in 1976, with the first fighter wing at Langley Air Force Base, Virginia, receiving the first operational units. Integration required extensive pilot training programs to master the aircraft's complex systems, including simulators for radar and weapons operations. Infrastructure adjustments, such as reinforced hangars and maintenance facilities for the F-100 engines, were implemented at air bases worldwide. The F-15's modular design facilitated rapid maintenance, ensuring high readiness rates. By the late 1970s, the Eagle was a cornerstone of U.S. air power. The F-15's combat record is unparalleled, with over 100 air-to-air kills and no losses to enemy aircraft. During Operation Desert Storm, 1991, F-15CS downed 34 Iraqi aircraft, including MiG-29s, using their radar and missile advantages. The F-15E Strike Eagle, introduced in 1989, expanded the platform's role to include precision ground strikes, with advanced targeting pods and GPS-guided munitions. Its versatility shone in conflicts like Iraq and Syria, where it conducted both air-to-air and air-to-ground missions. The F-15's adaptability and lethality cemented its reputation as a dominant multirole fighter. The F-15's success is evident in its production of over 1,200 units and its combat dominance. Its air superiority capabilities, driven by unmatched speed, maneuverability, and radar, made it a cornerstone of U.S. and Allied air forces. The platform's adaptability allowed upgrades like the F-15E and, later, the F-15EX Eagle II, which incorporates modern avionics and weapons. Its longevity stems from a design that balanced performance with upgradability, ensuring relevance decades after its debut. The F-15's influence is seen in successors like the F-22 Raptor, which adopted its focus on air superiority and advanced radar but added stealth. The F-15 program taught valuable lessons about cost management, emphasizing modular designs and long-term supplier contracts to control expenses. Its success underscored the importance of pilot feedback and iterative testing, principles applied to modern programs like the F-35. As of 2025, the F-15 remains in active service with the U.S. Air Force and allies like Israel, Japan, and Saudi Arabia. The F-15EX, introduced in 2021, features upgraded avionics, fly-by-wire controls, and compatibility with hypersonic weapons, ensuring its relevance against modern threats. Exports continue, with Japan and Israel upgrading their fleets. Despite competition from stealth platforms like the F-35, the F-15's combination of raw performance and affordability keeps it viable. Its enduring legacy is a testament to its engineering and adaptability, securing its place as one of history's greatest fighters.